Fortran, and today we're talking about quantifiers in mathematics. You may have heard it in English or grammar lessons where you got a few, little, much, many, or those stuff. Well, you might ask me, are we learning grammar? No, we're learning mathematics. But my dad always said that mathematics is one of the language. So let's prove it by today. Quantifier has two of them. One is for all, where it has an upside down A, and the one that has a symbol is called there exists, or some people call it for some. The definition of quantifier is that it is a quantity that specifies the quantity of space in domain. Let's say you got a big number or group of so many things that you just can't say it all. You could write it in a set, and you could name it x, and you say for all x, I mean every number that you mentioned before, or for some x, which is some of the number that you want to say of those group number. Get it? Okay, so just to remind you, you should know all of these things before getting into the topic, because we'll be using all of those things in our next lesson. Alright, so let's say we got an example here. For every real number x, x is more than 2. Notice every real number, that means you got for all. Real number x. For all x, that x is more than 2. X is more than 2. Oops, sorry. X is more than 2. So that means every real number is more than 2. Is that right? Real number means a number. Since negative number, negative infinity, 0, 1, 2, 3, and it goes on. So you still got that 0 and negative part. So this statement is false. As you can see, we will use these things in our example here. See our first example. For all x, when x plus x is equal to 2x, prove if it's true or if it's false. For all x means every x in the world, including everything. Yeah. So x plus x is equal to 2x. Is that right? I think it is. When you say 0 plus 0, that is 0, right? 1 plus 1, that is 2. So prove that. That means this is true. Or you could just say x plus x will be equal to 2x. Okay, our next example is that for some x, when x equal to 0, we'll get x squared more than 0. Is that true? For some mean one of them is correct, it means it's all correct. So when x is 0, so that means x is 0, 0 squared is more than 0. Is that right? No, 0 is not more than 0. 0 is equal to 0. So this means this statement is false. Alright, and our last example here. For all x, when x is more than 1, when our universe is 0, 1, 2, 3, and 4. For all x mean every x in here. Get it into here and it will get true. So is that right? Is 0 more than 1? I don't think so. So this means this statement is false. Just for the summary, I want you to know that for all mean every number in universe have to be true in order to be true. But if one of them is false, that means it is already false. And for sums or their x's, it means only one of them is true, the statement will be true. But all of them are false, that means everything is false. And just before we go, I want to show you something what you call a negation. Negation means something that is opposite. So when I say negation of for all, that means there exists. Negation of for sums or there exists is for all. Like a negation of for every real number x, x is more than 2. The negation here is that for sums of real number x, x is less than or equal to 2. Do you get it? Yeah, I think that's enough for today. Thank you for watching. Bye.